A 2-cent bank transfer shouldn't be dangerous. But recently, a transfer that small was used to completely compromise an AI assistant serving 20 million European banking customers. Security firm Blue 41 executed the attack by hiding a malicious payload in plain sight. They embedded instructions directly into the text of the tiny transaction's description field. A single small transaction packet enters the benign data pool. When a customer later asks their AI assistant about their finances, the system retrieves that poisoned data. The central AI node reads the hidden instructions and executes them, completely bypassing standard guardrails because the payload looks like normal transaction history. Connecting AI agents to real-world financial records turns a standard customer service feature into a highly credible phishing vector. Anything in a user's transaction history, even a transfer from a total stranger, can now hijack the assistant. The banking exploit works because the AI is essentially reading its mail without supervision. This represents a massive vulnerability for white-collar work, where we are increasingly receiving machine-generated outputs that no human has personally checked. To handle this, the AI coding agent market is currently splitting into two management styles. On one side, there's steering, where you watch the AI work in real time and redirect it as it goes. On the other, there's dispatching, where you assign a task and check the results later. Both approaches have unique failure modes. Steering suffers from theater, where the AI generates convincing conversation but lacks actual understanding of the problem. Dispatching suffers from completion theater, delivering finished work that looks polished but lacks underlying validity. The core question for the market is no longer about making AI more capable. The real challenge is determining exactly when an AI's output is trustworthy enough to accept without direct human oversight. Right now, developers face a critical engineering dilemma, defining the exact moment an AI should stop trying to reason through a problem and start using an external tool instead. A recent research paper titled The Deterministic Horizon provides a concrete answer, quantifying the exact point where an AI's internal chain of thought mathematically breaks down. Plotting reasoning steps versus accuracy, the line moves steadily forward. But between 19 and 31 steps, transformer models hit limits, suffering super exponential decay. Fine-tuning yielded under 5% improvement. This architectural ceiling means tool delegation is necessary for tasks requiring over 20 steps. Giving an AI unchecked autonomy to simply think harder guarantees failure on complex tasks. Safe delegation requires architecturally enforced boundaries and the ability to call external tools. Even if we solve the reasoning limit, every major language model today operates under a massive bottleneck, generating text sequentially, one word at a time from left to right. Google just released an experimental model called DiffusionGemma that attempts to solve this bottleneck. It generates text using the exact same underlying technique used to generate AI images. Sequential models predict blocks one by one, but the diffusion model generates a 256-token grid instantly, hitting over 1,000 tokens per second. Because the grid appears simultaneously, bidirectional attention allows the AI to look forward and backward, self-correcting mid-generation. This leap solves latency, but the sheer velocity and nonlinear generation make real-time human steering virtually impossible to maintain. The technology is forcing the industry even further into the risky dispatching approach. The developer community is responding to these vulnerabilities by building cages for these newly autonomous systems. 4 of the top 8 trending GitHub repositories right now aren't for smarter agents. They are agent discipline frameworks. This urgent push for oversight is happening against a backdrop of shadow IT. 90 other platforms like Spotlight by Backplanes are generating detailed session reports to turn massive agent transcripts into auditable evidence. The window between an AI simply writing code and an AI writing trusted code is now the most valuable gap in the software industry. Proving what an agent did has become just as important as the agent's capability to do it. These developer-level guardrails are now scaling to the executive level. The industry's reliance on voluntary safety pledges is being replaced by direct calls for binding legislation. Anthropic CEO Dario Amodei recently published a comprehensive policy essay demanding that governments regulate his own industry with the strictness of the aviation and pharmaceutical sectors. Amadei proposed concrete legislation requiring mandatory third-party testing before any frontier model can be shipped. The fast and loose deployment of experimental tech is being locked down. The geopolitical stakes are rising alongside the regulations. Recent reports show foreign influence operations are now specifically targeting U.S. AI policy debates, turning governance itself into a battlefield. The final obstacle is structural. Institutions are trapped by what researchers call the gravity of the present, relying on slow, multi-year planning cycles that fail to adapt to AI capabilities, doubling every 6 to 12 months. We are moving beyond the goal of simply building high-capability models. The focus has shifted to engineering the specific regulatory and cryptographic systems required to safely deploy them.